2003 A-B test, and I kind of selected the multiple choice questions that fit into our first derivative review, which also would include limits and continuity. So it looks like this first one, they just want to take the derivative, and you have to use the power rule and then the chain rule. So I brought the 2 down, and then I multiplied by the derivative of the inside. So the 2 and then the 3x squared kind of form the 6x squared out in front. They want to know is y equal to an asymptote for which of the following graphs? Well, this is like the definition of a horizontal asymptote, right? A horizontal asymptote is the y value the function approaches when you go way to the right. Well, that's what this is saying. Look at the limit of the function as x goes to infinity, and it's 2, right? This is the definition, the calculus version of this. Here we have quotient rule, right? We want to find the derivative of this, so just be careful, and it looks like they simplified a little bit, but nothing complicated, right? The quotient rule is when you have a function u over v, and then the quotient rule is v u prime minus u v prime all over v squared. Here we're looking at the limit as x goes to infinity, and we're going to look at a big dog versus the big dog. It's a cubic over another cubic, so I'm just going to compare the two cubic terms, and it looks like the ratio is just 1/4. 4, I don't really know what happened to 4, but, oh, that's me doing the work for 4, I see. All right, that's me showing you the algebra of 4. Kind of jumped on me there. I really want this to be continuous, don't I? Okay, so, all right, now we're actually back. Number 7. Which of the following statements is true about f? This is the graph of f prime. So f is increasing from -2 to 0, right? This is as a positive derivative, so it's going to be increasing, right? A positive derivative is when the function is increasing. F prime of 0, it looks like I'm just going to take the derivative of this logarithm and then plug in. Here's the derivative, right? The derivative of a logarithm is 1 over u times u prime. This is the derivative of the inside. We want to say when is it continuous but not differentiable, okay? Here, no limit, not continuous. Here, there is a limit but not continuous. Here, it's continuous but it's not differentiable. All right, we want f prime, and f double prime to be negative for all real values. So we need f to be negative, so it's got to be below. The derivative is negative, so it's got to have a negative slope. And the second derivative has got to be negative, so it's concave down, or it's got a bigger and bigger negative slope, right? The slope is decreasing, which is b. This is product rule, right? So we have a derivative of u and v. The derivative of uv is uv prime plus vu prime, meaning the first function times the derivative of the second function plus the second function times the derivative of the first function. And then it looks like I factored something out. And I only factored it out because they did. Otherwise, on the test, you can just leave it like that. Uh, 15, which of the following intervals is f decreasing? F is going to be decreasing when the derivative is negative. They gave me a derivative equation, and there's 2 things. Number 1, you got to make sure you figure out where the derivative is equaling to 0, but you also have to take into account where the derivative doesn't exist. The derivative doesn't exist at 0. And so I have 0, and I have then the cube root of 2. Both of these are my critical values. I do a sign chart, and I want to know when f is decreasing, so I want to know when the derivative is negative. The derivative is negative in between there. All right, I want the line tangent of the graph at the point passes through this point, then f prime is this. Okay, so I just found the slope. Okay, and that one's pretty easy. Remember the line tangent of the graph at that point. Okay, that's not bad, right? Don't overcomplicate that. It's kind of just algebra. The graph of f is concave down when, and this is my function, and so I took a derivative, I simplified, I took another derivative, and then I found out where the second derivative was equal to 0 at -2, and I want it to be concave down, so I'm looking for when the second derivative is negative. Okay, it has exactly 2 zeros, I'm showing you g prime values, and then g is decreasing on which intervals? Okay, so I'm just looking at there, right? This interval right here, that's when g is decreasing when g prime is negative. All right, the curve has a slope of 2x plus 3. Okay, so if the slope is linear, meaning the derivative is linear, the function is going to be quadratic. So really, this is like a separation of variables. I'm not positive this is in this unit, but you can handle it, right? This is the derivative, so let's do reverse power rule and increase the power by 1 and divide by the new power. And then I want it to pass through the point 1, 2. So if I know 1 is an x value and 2 is the y value, I can find c, and then I can find the particular quadratic that fits that. All right, what I want here. All right, if I have this, if the limit exists, that means the two y values have to match at 3. If it's continuous at 3, well, then they have to match, and then this has to be greater than or equal to 3. And then if it's going to be differentiable, it's got to be continuous, and the slopes have to agree, but the slopes don't agree, right? This has a slope of 1, and this has a slope of 4. So definitely is a corner there. So it does have a limit, and it is continuous. This one, all right, which does it have a point of inflection? And so if you look here, there's no sign change at b, right? X minus b squared. The squared part makes it so there's no sign change, but really you just have to look at the graph. There's only going to be a sign change at a and 0, right? The second derivative goes from positive to negative and then negative to positive. Right here it goes from positive to 0 to positive. No sign change, no point of inflection. So only in these two spots. This is the fundamental theorem of calculus. Again, not really in this exact section, but you should be reminded that the derivative and the antiderivative are inverse functions of each other. You just have to take into account the chain rule. So you do have to take the x squared and put it in for t, which will make it sine x to the 6th, and then you have to multiply by the derivative of x squared, chain rule, and get that 2x out in front. This particular question is not on the test, but you should remember it. I mean, you were taught it in AB. Which the following is an equation for the line tangent to the graph when x is negative 1, right? We want to write in a tangent line. We have to find the derivative, find the slope at negative 1, which is 7, and then we use point slope or whatever you want to find the equation of the line that has that point and has that slope. What is the slope of this curve? Well, we're going to use implicit, right? So we're going to take the derivative of like 3y squared and get 6y, y prime. The derivative over here needs a product rule. So I take the derivative, and then I guess I wanted to know what y prime was at 3, 2. So I plugged in 3 for x and 2 for y, and then I found y prime. Okay, so we have all this. We know g prime is positive, which means g is increasing. G double prime is positive, meaning it's increasing at an increasing rate. Okay, so I got a point 4, 12 and 518. That's got a slope of 6. So then if I know it's increasing at an increasing rate, going from 5 to 6 has to be bigger than an increase of 6. So it can't be 24, and these are just dumb, right? And for sure it's going to be increasing. So it's got to be 27. It doesn't have to be 27, but 27 is possible. All right, this is kind of like parametric, right? An object is moving back and forth on an axis, and I know the velocity, and I also know that the acceleration is just the derivative. So I'm just going to take the derivative of that thing at 4, and I'm going to use my calculator to accomplish that. Here, which the following limits exist? This limit is fine, this limit is fine, this limit is not fine. The left does not equal the right, which is the definition for a limit to exist. Here, it looks like we have 2 points, and it's continuous and differentiable. So it could just go straight from here to here. There does not have to be a c where the derivative is equal to 0. There has to be a y value of 0. There has to be a y value of 3. There has to be a slope of 3 because the average slope is 3. So somewhere the instantaneous slope is 3. And this is just saying that there's some maximum value, but there's no guarantee that the derivative has to equal 0 in between here and here. The x-coordinate of the point of inflection, it looks like I just graphed f prime and I looked for the maximum. Again, the maximum of f prime would be where a second derivative is equal to 0, right? A positive slope to a negative slope on f prime is where f double prime goes from positive to negative, which is a point of inflection. And that's it. Okay, that was the 2003. Again, most of those questions relate to our first unit derivatives, and hopefully this video has helped you kind of walk through that.